Welcome to Chapter 8, Robots, Sensors, and Motors. This lesson will focus on utilizing a standard webcam using the image view topic and a built-in camera into a laptop. So there'll be a series of demonstrations on how we can look at the image view topic produced from a standard webcam. So on the left-hand side, I have the virtual environment. So Ubuntu 18.04 running with ROS Melodic. Right-hand side, I have the Chapter 8 from the ROS textbook. So of course, there's a number of robots that are supported through ROS. Here's a quick snapshot of a few of them: the PR2, the Turtlebot 2, and the Turtlebot 3. And then a series of other robots. So there's literally hundreds of robots that are supported by ROS, and a number of different type of robots. So if it's a manipulator, a ground vehicle, an air vehicle, surface or subsurface. Of course, ROS supports a number of different types of sensors. So here's a snapshot of various LiDARs, depth cameras, RGB cameras, and standard web cameras. So really the focus for this lesson is a standard web camera and utilizing one that's built into a laptop, and then subscribing to the image topic and displaying that. So there's a number of packages for standard USB cameras. One that's very popular is USB Cam, of course, and then we will today be using UVC Camera, so we'll use that package. The first step is when you're using your built-in web camera on your device. It may not be compatible with USB 2.0. Thus, we will open the USB controller, and if you're set on 2.0, set it to 3.0 for compatibility. So hit OK, and then we'll power on our VM. So once the VM is powered on, we can actually look at a number of devices that we can connect to. So as that's booting, we'll look down here at the bottom bar. So you'll see I have a standard webcam connected to my laptop, but I also have a built-in webcam. So the Realtek integrated webcam FHD. So that's the webcam that we'll be using for this particular demonstration. So if I click on that and then connect it to the host, the webcam now that's built into my laptop is connected to my virtual machine. So of course, next step is to log into my VM. And again, you can utilize LSUSB, ls/dev to look at the different devices that are input devices. I'll briefly show you. So if you say ls/dev, here we see video 0. So that's the camera that we'll actually be utilizing in this demo. So for UVC Cam, you need a number of packages installed. So anywhere where you see kinetic, obviously you want to replace that with melodic. So let me just clear screen. So sudo apt get install ROS melodic UVC camera. So in this case, I already have the package installed. So it's already the latest version, and no need to do an update. So now I will install the image viewer, which is already installed as well, but just to demonstrate how that's done. with this command, and then the second command for RQT view. And that's installed already as well. So to run these, basically we're going to need 3 windows. So if we were to create a launch file, we could load all of these packages at once. So in this case, since we're, it's a number of demonstrations, we're just going to run our core process. So ROS core, and then I will run the camera node. So ROS run UVC camera, and then UVC camera node. So this is actually subscribing, or it's leveraging /dev /video 0, which is the built-in webcam into this laptop. There is a warning here on calibration, so we're not going to calibrate in the text. I'll show you briefly. There is a calibration procedure where you're using these checkerboards, and you run a script to calibrate your camera, and that calibration file is then saved and then leveraged every time you run the your camera node. We're not. That's beyond the scope of this particular lesson, but that's why we're getting a warning here. So we're running the camera node, and if you look on this window, we have a number of topics. And these topics match the same topics that we see in the textbook. So really we're just going to look at image raw, right? There's a compressed version, there's a number of topics here, of course. We're just going to look at the raw image that's generated from the camera, and to do that, ROS run image view, and then the actual name of the topic we're looking at. So I'll just copy that and paste. So here is the actual image. So you can see the Army mule in the background, and this is a raw image that we are displaying in this image view. So there are other options. So one is RQT image view, and that's more like a GUI. So I'll run that as well. So copy and paste. So this much, looks just like image view. However, there's a drop down. So this drop down, we can actually subscribe to different topics. So this is image raw. Right, there's our mule in the background, and here's a compressed version. Actually, it's very difficult to even tell the difference. So maybe if you were transmitting over a Wi-Fi connection, then you may want to compress the image and save on bandwidth. There's a lot of other options in here, of course, as well. So just think of it as a GUI for viewing images. And then finally, we'll just look at RViz, which we've looked at in the past. And again, when you run RViz without any configuration, it's just the standard RViz window that opens up. So here, really just there's no robot model, there's nothing other than this grid and a map. So we're going to go down and add an image. So we'll hit OK, and then I'll make this a little bit larger. So what we have to do is ensure that we are actually subscribing to the wrong topic, or the correct topic. So right now we're not looking at anything, but here now I look at image raw. And there's my image in RViz. So again, 3 different techniques. So this robot, or this camera could actually be on your robot. And now I'm looking at what the robot is seeing. And then of course, here, if we had the robot model loaded, as we've seen in the other demonstrations, we would see that in the perspective of the robot. So let me close that and exit out. So as you can see, 3 different versions of really seeing the same type of image. And with that, I'll end this demonstration and look forward for upcoming ones.